In this presentation, we will learn how to delete the first node of the circular singly linked list. So let's get started. Let us suppose we have the circular singly linked list and tail pointer is currently pointing to the last node of this list. Our target is to delete this particular node, okay? For this purpose, I'll keep a temp pointer which must point to the first node of this list. That's why I'm writing these two lines of code. That is struct node star temp, which will actually declare a temp pointer. And then after that, temp is equal to tail next, which will update the temp by the address of the first node. That is why you can see over here the temp is pointing to the first node of this list, right? After this, we should update the next part of the last node so that it can point to the second node of the list, right? Obviously, we have to update the next part of this node so that it can point to this node. Because after deleting this node becomes the first node of this list. That is why it is important to update the next part of this node so that it can point to this node. For this purpose, I'll put this line of code, that is tail next equal to temp next. As simple as that. Here we will update the tail next by temp next, which is 2000, right? So let's just update it, and you can see over here that this node is now pointing to this node. Now we can free this node without any problem. We can do this by using free function, and here in this free function I'm passing temp so that I can free this node or delete this node. After this, I will just put null over here by using this line of code. And that's it. That is all what we need. The time complexity of this program, this whole procedure, is obviously constant. It doesn't require any traversal at all, right? So the time complexity is big O of 1, okay? Now let me just show the complete code in code blocks. Here you can see this is the complete code written over here. We have a struct node, then we have add to empty function, add at end function, which are used to create a complete list. There we have a create list function, okay? We already know what this function does, right? After this, we have this print function, which is used to print all the elements of the list. And here we have del first function, okay? In this del first function, first we are checking this condition. If tail is equal to null, then simply return tail back to the main function. If tail next is equal to tail, that means if there is just one node in the list, then you just have to delete that node, right? Here we should simply delete that node, then tail must be updated by null, and finally this must be returned back to the main function. Otherwise, we will do this procedure which we have seen already. Here in this main function, you can clearly see that tail pointer is declared and it is initialized by null. Then after this, create list function is called, and then this printf function is called in order to print this message list before deletion. Finally, print function is called in order to print all the elements of the list before deletion. Then del first function is called in order to delete the first node of this list. Again, this printf function is called in order to print this message list after deletion. Then finally, print function is called again. Let me just execute this code. You can see over here it is asking us to enter the number of nodes of the linked list. Let's say I entered 3. Enter the element 1. Let's say it is 78, then 90, then 98. You can see list before deletion is 78, 90 and 98, and list after deletion is 90 and 98. That means the first node of this particular list is now deleted, right? Let me just execute this code once again. This time I will enter 1 and let me just put 90. You can see the list before deletion is 90, but list after deletion is no node in the list, right? Because after deleting this node, there will be no node in the list. Let me just execute this once again. Here you can see it is again asking us to enter the number of nodes. Let's say this time I enter 0. You can see the list before deletion is no node in the list, and list after deletion is no node in the list. And that's it. This is all what we need, right? Okay friends, this is it for now. Thank you for watching this presentation.